Number 1, estimate to equally partition and label the fractions on the number line. Label the wholes as fractions and box them. So looking at the number line, I see that we're working between the whole numbers 2 and 3. And here, fifths tells me I need to separate my number line into 5 equal parts. Estimate tells me that I don't have to measure it exactly, so I'm just guessing. Starting at the whole number 2, I know that I have more than one whole. So this is actually 10/5. And one way that I was able to get that answer so quickly in my brain was that I thought, well, what is 5 times 2? If I have two groups of 5 equal parts, then I'll have 10 parts. And so that is 10/5. And then I can count to my next section, 11/5, 12/5, 13/5, 14/5, 15/5, and I can check to make sure that that whole number there is 15/5 equals 3 whole, because I can again check to see is 15 a multiple of 5. 5, 10, 15. 3 times 5 is 15. 15/5 is equivalent or the same as 3 wholes. I need to box those fractions, 10/5 and 15/5, because my directions told me to do so, and the arrow at the bottom of the page tells me that there's another question for exit ticket 16. Number 2, draw a number line with endpoints 0 and 2, label the wholes, estimate to partition each whole into sixths, and label them. Box the fractions that are located at the same points as whole numbers. Lots to do here. Let us begin by creating a number line and labeling the endpoints 0, 2. In between those whole numbers is another whole number about halfway called 1. Now I can estimate to partition or split each whole into sixths. So I will draw 5 lines to create 6 equal parts in between each of my wholes. Now I need to label them. Okay, I'm going to just change the color so it's easier to see. Here I have 0/6. Take me to that next section. That's 1/6, 2/6, 3/6, and so on. It's important that we label every fraction so we can see. I know your handwriting and your labeling will be much, much neater. As a reminder, you are not erasing your work if it does not, if it is not correct, because mistakes help our brains grow. Whew. 11/6, 12/6. This is tricky to write with neatly. Okay, apologize for some of that messiness in the middle. But now I can box the fractions that are located at the same points as whole numbers. So I can box in 0/6 as an endpoint, whole number. 6/6 tells me there's one whole. And here at my number 2, my 2 wholes, I have 12/6. Also checking in using the same strategy as earlier. 6 times 2 is 12. 2 groups of 6 equal parts would be 12. 12/6 is correct. Let us move on. Locate and label the following fractions on the number line. We're looking at 7/3, 2/3, and 4/3. So the first thing that really stands out to me is that all of the denominators are the same. They're all the number 3, telling me that each of our wholes are split into thirds. So the first thing I'm going to do on my number line is split each of my wholes into thirds. Beautiful. Those 3 equal parts. Now I'm just going to begin counting in my head and then label the fractions that I need to on the number line instead of writing all of them. So I know this would be 0/3, 1/3, oh, there's 2/3, less than 1/2, because 1/2 would be 3/3, and then there's 4/3, which makes sense because the numerator 4 is larger than the denominator 3, and so 3/3 would be 1/2, and now I know I have more than that. 5/3, 6/3, and there is 7/3. And that's all I needed to do for this page. Super important to recognize that these numerators are larger than the denominator, reminding us that they are larger than 1/2, potentially even 2, and that when the numerator is smaller, it is talking about pieces of a whole, um, smaller or less than 1/2. The arrow tells me I need to go on. Katie bought 2 one-gallon bottles of juice for a party. Her guests drank 6/4 gallons of juice. What fraction of a gallon of juice is left over? Draw a number line to show and explain your answer. I can think already of how much juice might be left over, but I'm going to use a number line to show my thinking and prove that it's correct. So I'm going to label my endpoints 0 and 2. And I know that it's going to be 2 because I look back at the question and see that it was 2 one-gallon bottles of juice, and I'll put 1 on the number line there so I know where that first gallon starts and ends. So looking at the fraction 6/4, the 4 in the denominator tells me that each gallon is being measured in 4 equal parts. If I can think in my head about how much 1 gallon of juice would be, that would be 4/4 to get 1/2. And I'm jumping there because I see that the numerator is bigger. And when the numerator is larger, it means I have more than 1/2. So anything more than 4/4 would be closer to my second gallon here, my second whole. So that would be 5/4. And then there's 6/4, and that's what we're looking for. So Katie's party guests drank 1/4, 2/4, 3/4, 4/4, there it is, 5/4, 6/4, leaving this many fourths unhad. And so I see that there are 2/4 left. So Katie's guests left 2/4 of the juice left over. And I know that because I was able to label my number line and the denominator told me that each gallon was split into 4 equal parts. Moving on. It says place 2 fractions on the number line, circle the fraction with the distance closest to 0, then compare using the greater than, less than, or equal to sign. I love comparing fractions. So here we're looking at fractions with the same denominator, which is both 5, which tells us we're splitting our number line into 5 equal parts. I draw 4 lines to make those 1, 2, 3, 4, 5 equal parts between 0 and 1. And 3/5 on my number line would go 1, 2, 3. 3/5 would go here. I'm gonna write a little on my directions so I have enough room. And then I could go back and think again. Here would be 1/5. I can put these fractions both on the same number line without having to do any extra drawing because the denominator is the same, so we're talking about the same size equal parts, and 1/5 is closer to 0, which means 3/5 is greater than 1/5. And that makes sense to me also because in the numerator, 3 of the same size pieces would be greater than if I only had 1 of those same size equal pieces if we were talking about candy bars or slices of pizzas. Like if I ordered 2 medium pizzas and I ate 1 slice out of the 5 pieces in my medium pizza, and in the other pizza I ate 3 slices out of the 5 in that medium pizza. I obviously ate more from the box of pizza that I ate 3 slices of. So now we can look at B, and we're comparing 1/2 to 3/4. So if I put 1/2 on my number line, it means I'm splitting my number line into 2 equal parts, and here is 1/2. Right? This would be 1/2 of my number line, and I'm comparing that to 3/4. So I will choose another color, and underneath I'm going to compare my fractions by splitting the same number line into fourths. So I'm going to split it into 4 equal sections. So there's 1/4, 2/4. Here is that 3/4. Not very prettily written, but it's there. And there's 4/4. I'll even go back and just do my 0/4 for consistency. But I can see here that 3/4 takes me all the way out here farther away from 0 than 1/2 does. And so therefore 1/2 is closer to 0 and therefore is smaller or less than 3/4. In comparing my fractions with different denominators, I can always think of the saying we've talked about before: the greater, the bigger the denominator, the smaller the piece, but I have more pieces here. We can see that 1/2 is actually equivalent or the same as 2/4, and that helps me to also compare these fractions. As we move forward, we'll talk more about that as well. Let's follow that larger arrow to see what's next. Mr. Brady draws a fraction on the board. Ken says it's 2/3 and Dan says it's 3/2. Do both of these fractions mean the same thing? If not, which fraction is larger? Draw a number line to model 2/3 and 3/2. Use words, pictures, and numbers to explain your comparison. Immediately, my gut reaction is to say that no, these aren't the same fractions, but I need to show my work as to how I know that. So I'm going to draw a number line. I'm going to label it with the endpoints 0 and 2. I'm going to do this because the fraction 3/2 makes me think about how it may be a fraction greater than 1 whole, because 3 in the numerator is larger than the 2 in the denominator. But I will start by first drawing my 2/3, since it's the fraction that came first. So I'm going to split the number line into 3 equal pieces, and 2/3 would go here. I can check that because this would be 1/3, and now I have bolded, shaded, sort of created 2/3 there on my number line. If I change my color, make it a little darker, and I create halves in my number line, this would be 1/2, this would be 2/2, and to here would be 3/2, and my thinking was correct in seeing that 3/2 is greater than 1 whole, and so this is why these fractions are not the same. Even in comparing the denominators, they did not end up being equivalent fractions, mostly because 3/2 is greater than 1 whole and 2/3 is not. It is less than 3/2.